for you in this competition. Yesterday we had the opening ceremony and we had the coding workshop as well. So today we're going to have the engineering and research workshop focusing on maybe other aspects of the project that you may want to focus on, or that will also be important. So we have Surath and Eduardo who will introduce themselves. They're going to be leading us in this workshop today. So I'll pass it on to them to continue on with the workshop.
Thank you, Blake. Welcome everybody to the second workshop of the event. We're mainly focusing around engineering and research, and like Blake mentioned, it will be led by Surath Gomis, who is here with us.
Hey everyone, my name's Surath. So I did my PhD graduate degree in electrical and computer engineering at the University of Toronto, and now I'm currently working in the biotech industry.
And I'll be also co-hosting this workshop with him. My name is Eduardo. Currently I'm a graduate student in the Department of Cell and Systems Biology, and I am a Master's of Science candidate in the field of neuroscience. And so with that said, we want to, today what we're aiming for is to use our experiences and our expertise to kind of give you more of an idea of how the components of research and engineering are going to be used in the context of this competition, and hopefully give you some tips that will help you get started on the development of your project. Okay, so before we start, just so everybody is aware, some of the talking points that we'll be going over are going to be first, finding the problem. How do you look up specific information to identify a problem? And the next step would be to then, how to then ask a question based on that information that you have. And ultimately, how to state a solution. And then the last step, of course, once you have your solution, is you want to validate it. And in order to do that, you'll be able to have to create a product that somehow its function addresses the problem that you're trying to solve. So in the context of research, I'm going to be using my own experience as an example. In my lab, the main focus is around these cells that are called retinal ganglion cells. And these cells are the ones that line the retina, and are the ones responsible for sending visual information from your eye to your brain. So without these guys, you would be completely blind. And you cannot, I guess you can expect, just because it's such a vital part of the visual system, there's a lot of information out there about these cells. And usually as a master's student or a PhD student, the first thing that you do when you get into a lab is to start looking for a problem to solve, which you're going to base your entire research around. And the way that you would do that is to first look up what's called a literature review. And these review papers are great because what they do is that they'll give you more or less a breakdown of the current studies about retinal ganglion cells that have been done to date. So that's really good because you get to see all the different components and what people are trying to solve in each of these categories. And the way that we kind of tackle this is that we use some very useful tools that are the search engines. They're academic search engines because they serve repositories for all types of studies that we can then go in, look them up based on what we find in our review papers. But of course, in a review paper, as I think is very clear, it's a lot of information that's very condensed. And if we were to just take the raw information and just like throw it into these search engines, we will be spending days trying to find what we're trying to look at, or trying to find an answer to the problem that we're currently found in the review paper. So as graduate students, we need to be very efficient in the way that we create our queries. And by queries, I mean your search that you put in the search bar. So once you put in the search bar, the idea is that we narrow it down so much that the results that we get are extremely specific to the question that we're trying to answer. And what's great is that you guys are actually going to be undertaking a similar journey, where I believe this year's problem that you're tackling is fostering sustainable communities through tackling issues related to disposable waste. And it's a very interesting topic, And I think everybody's idea right off the bat to try and to get an idea of what this means would be what any normal person would do, would be to copy and paste this and put it into the most popular search engine in the world, Google. So what happens if we just take this and just throw it straight into Google? What you get is actually a lot of really cool and interesting results. But the problem here is that when you throw something just raw like this into Google, you get just a lot of results that are not really interconnected to one another. And that kind of it gives you a lot of choices, but also gives you a sense of confusion, because they presents you with 100 avenues to go into, but you're not very certain as to, do I want to go to this one or to this one? You kind of have to go through filters through a bunch of stuff before you find what you need to do. And with the context of the hackathon, time is of the essence. So the faster you get to that point where you find the problem and you can get to your solution, the better. So how do we do that? So the most efficient way to do this, it's something that I do myself when I find giant chunks of paragraphs in my review papers, is that I take the keywords that I'm interested in. So these keywords in this sentence would be sustainable communities and disposable waste. So what you would do then is you would take these keywords and then you would put them into Google's advanced search engine. So for anyone that wasn't aware, Google has a really cool advanced search option that you can find in the settings here. And that will open up this menu. And within that menu, you can click the advanced search option. And that will bring up this dashboard. And this is a really cool dashboard because it not only allows you to search using just these keywords, but it also allows you to, for example, search by specific language, a region, last update, etc. So you can get really specific. But for the purposes of this competition, I think it's just as simple as putting the keywords themselves. And where you would put in these guys in will be in this exact word phrase, where you essentially would put the keywords between quotation marks, and then you would hit search. But you can go one step further and add a little bit of your creativity in this search. So you would get really good results just by putting these two keywords. But if you're interested in something already, so let's say myself, I'm really passionate about education. I might want to look into what kind of results relating to sustainable communities, disposable waste, can I find within the context of education? So then we click search. And what we get is two very interesting results. The first result is the Turing-Huseman guide. It's a giant guide that was provided to schools to teach them how to put together activities, lessons, and curriculums around teaching students about sustainable communities and the environment. And on the other search, what we got is actually an outreach program that brings students to a national park and teaches them what are the steps to maintaining the parks and what can they do to help. So what we can gather from these results is that there seems to be an emphasis on teaching young students about sustainable environments and kind of what are the steps that they have to take in order to preserve our environment and making smart choices in the future. So based on this evidence, I guess the question that we can gather from this is, if the goal is to teach our younger generation about the environment, so they can make smart choices in the future to maintain it, how can we effectively promote environmental sustainability to our youth? So now that we have the question, you're already in a good spot, because now that you know what you're trying to answer, now it's up to you to find a solution. And here's where the creativity comes into. So you already spend your time looking up and reading about the problem. You have the problem. Then you have to look at it and see how would you solve it. So if it were up to me, the way that I would solve it is to first create a hypothesis. And then what a hypothesis is an educated guess based on the current information that we have. And the information that we have is that the demographic that we're targeting are children. What we want to teach them is about environmental sustainability. And we want to teach them in a way that is relatable and accessible to them, sort of like games and fun activities. So what my hypothesis would look like would be something like, oops, games and playful activities could serve as an efficient tool, educational tool for students to learn about environmental sustainability. So this is, at this point, you have reached your potential solution. This is a very important statement because this is what's going to guide your project going forward. So once you have the idea of, I want to provide children with a fun activity or a fun product that they can use to play, but also at the same time teach them about the environment, now you can start thinking about, well, now I need to prove that this is correct or is possible. And the way that you do that is by starting to plan out your project. And now I'm going to send it over to Surath, because he's going to be the one that's going to guide you through how do you begin planning and building your project.
Great. Thanks, Eduardo, for that great introduction about how you do research into looking at the problem, how you devise your question, and then finally formulating that hypothesis. And Eduardo leaves that on a really good, point to take your next step, because once you have your hypothesis, what you need to do next is to test it out. So, in a lot of scientific fields, that might be just going into the lab, doing a bunch of experiments to see if you can prove your hypothesis correct or incorrect. But in the engineering field, a lot of times we're going to actually just build the solution. So this is, what I'm going to talk about for the next little bit is the engineering portion of your project. It could be, coding if it's coding competition. But for us here, for the engineering side of things, it's going to be, how do we build a solution with some household items? So let's take you through a potential solution here. So Eduardo, if you want to click one more, great. So thinking about our hypothesis, we wanted to teach young kids about environmental sustainability, but we wanted to do it in a fun way. And our hypothesis was we could use games to teach kids about the environment. So what we want to do is, build a game that's fun and engaging. So what we want to do first is let's think about, step by step, all the different portions of this hypothesis. So let's think about the game. Let's say we've decided we want to make a game with 8 different options that'll determine 8 different actions. So you can kind of see here, we have this kind of wheel of numbers 1 to 8. So those could be different options that lead to, different actions that we can have in our games. And that little white circle there is a little ball that will determine, whichever piece of the pie it's on is the option that we're going to take. So this is pretty basic, but how do we relate that to sustainability? Well, let's think of how could we incorporate putting a wind turbine into the mix so that the wind turbine could actually select these different options. So, well, how would that work? Let's imagine you have some gusts of wind that are blowing through, that are coming and turning the wind turbine fins or the blades. And what we can also see is that when it turns, it'll push this little red flag that we have here around the axle of the wind turbine. And when the wind turbine spins, it also spins the flag around. And this little flag will push around that little white ball into the different one of the 8 options that we can choose from. So that's a good start. It sounds like it could be a game. We don't necessarily know where it's going, but let's kind of think about, how can we build this wind turbine first? So this is the planning your project step and choosing your materials. So again, remember with this activity that we're doing in SRHacks, we're expecting only a very basic prototype. We want you to use items from the home and also keep it simple, because a big part of the engineering process is that sometimes you want to choose the simplest solutions, because there's a lot of benefits to that. It keeps the complexity down, so it makes it easier to build and easier to actually create a solution, keeps the costs down a lot too. And for this project itself, we want you to find things around the home and be as creative as you can with those things that are really easily accessible to anyone, that they can find at home. And also, we just want to make the user experience very simple too. We don't want to make this a really complicated contraption that is not going to be fun. We want it to be fun and easy to use. So let's think about some materials we could use to build this kind of solution. So first, let's look at the main axle or the axis of the wind turbine itself. So there's some kind of considerations we want to think about. We want it to be something that's rigid, because as wind's blowing by, we don't want the whole contraption to topple over. So that's one consideration we could think of for material. So what would be good? Well, maybe something like a skewer. So a little barbecue skewer. So something like that, it's pretty rigid. It's that kind of piece of wood. And then to make sure that it doesn't topple over, we also want to have a really good base. So Play-Doh or any type of plasticine would be a great base. And what we want to do is perhaps make this Play-Doh kind of sculpture very tall with a hole in the center so that the skewer can be stuck into it and can spin very freely through the Play-Doh. So that's one option that we could do. Very simple materials you can find around the house. Maybe you have some younger siblings who have some Play-Doh as well. So now we have this kind of little base. So now where do we go from there? Let's think about the spokes, where the fins would attach to for the turbine. So for something, considering wind that's blowing by the turbine, we want these fins to spin. Well, in general, one of the considerations we could have is let's try to make these fins very light. Because the lighter they are, probably the better they'll spin around. So straws could be a great option because unlike the skewer, the straws are hollow, which makes them a lot lighter. They're usually plastic or even paper straws. They're very light. So that would be a great kind of base to put our little fins on. But now as the wind comes by, if they're hitting straws, it's, there's not much surface for the wind to kind of blow and spin them around. So what could we have to catch that wind? Before we get into actually, let's talk a bit about how do we actually keep the straws up there in the first place. So there could be a few options for that. We could use rubber bands or different beads that could hold those straws kind of up at the top of your skewer so that they're not falling down. You can use some glue or things like that to hold it down, let's say for the beads, or the rubber bands can kind of just really hold it tight in place. But yeah, so now with that, in place at the top of a wind turbine, what could catch the wind? So one thing that could be really good is a ketchup cup. So a ketchup cup, if you attach these onto the end of your straws, that has like a nice little pocket that could catch a lot of wind. And even those ketchup cups, if you didn't know, you could actually kind of spread them to make them a lot larger by kind of pulling at the top corners to make it even a larger container. And, the greater surface area means that, so the greater surface area means, a larger kind of surface, more wind can be put onto that surface and you can have more wind pushing against your wind turbine to cause it to spin even more. So there's a lot of different considerations you can have to collect as much wind as you can if you do want to spin the wind turbine faster or more efficiently. So now that's done. We want the flag on the bottom there. Something easy we could use is construction paper. So we could attach it with glue onto the skewer itself, or we can wrap it around if we didn't have any glue and kind of crimp it into place. There's a few different options that you have there. So kind of looking at this design overall here, we see a lot of different options for materials for all these different components, but this is just one design. So in the engineering design process, when you're building your first solution, you think of, thinking about all your different objectives of, having light materials for your wind turbines, having very rigid kind of axle for the post of your wind turbine. Those are some of the things you want to consider in one design, but perhaps you can think of different options you could use for all these different materials. So those are considerations for alternative designs. Because, for example, let's say instead of having the skewer in the Play-Doh spinning around, what if the skewer was stuck rigid in the Play-Doh? The skewer doesn't spin, but just the wind turbine portions on top, the fins spin, let's say around those beads, because those beads could pretty freely spin around the axis of the wind turbine. And then another thing you have to think about is like, well, how do we keep the beads up there without falling down, but still be able to spin around? So that could be another design you can consider, thinking through the solution of how you'd keep them up there, how you keep them spinning. So there's many different solutions, even just using the same materials. And those are kind of the alternative designs you could have. And when it comes to the engineering design process, one of the big things is iterating in your designs, because we don't expect a solution to work first perfectly. A big part of engineering is trying, building, and then iterating. So seeing what worked, seeing what didn't work, and improving from that as you continue on with your project. And those are huge things that we want to see with SRHacks, is kind of that improvement in your design process and how you thought through your solutions. So definitely it's something to keep in mind as you're doing your planning. So now, after you've done your planning, so now you want to consider, okay, well, how is this going to be a game? How is this going to satisfy our hypothesis? How are we going to demonstrate that our hypothesis is correct, or maybe it wasn't fully correct? So one thing we can do is using this turbine to spin and causing this ball to go into those 8 different options. What if those 8 different options kind of lead to choices in a Jeopardy game? So, as you can see here in the panel, you have options 1 through 8 and a bunch of different questions that you could have. And these could be questions that you devised that are related to environmental stewardship, sustainability, and all these different things that could help youth learn about the environment. So this will be a great solution, and one really great way to have a product for demonstrating your hypothesis. But as I mentioned before, with the engineering design process, you're iterating a lot. So what if it didn't work at the start? So let's say, for example, when you're considering your wind turbine, maybe as this ball is going around, the circle here of the 8 different options, wait, what if we didn't consider that the ball could just fly right off of that surface? So one thing you could do is have some type of walls that you'd attach onto this base. So as the ball kind of flows or circles around, it's not going to fall off because it has now this little railing or this little guide that makes sure it stays within the circle. So that's something we might not have thought about, right off the bat. But as we design and build it, once we built it and tested it, we see these things that we need to change and we make improvements. And that's just all part of the engineering design process.
Okay, thank you so much, Surath, for that detailed talk about kind of fundamental engineering concepts that are going to be, I think, instrumental in I think all of our participants is thinking about how they're going to put together their projects. But one thing before I move on to the closing remarks is I want to return to the previous slide just to make an emphasis on the design that we have here. So this design is simplistic, and this was just not meant to be just for the sake of not making the presentation overly complicated. But this is what we wanted to show you. We want to show everybody here to just give you an idea of what we're expecting from everybody. There have been a couple of questions in the Discord server about the complexity of the projects and people kind of feeling a little bit overwhelmed as to how far they should take their projects. And we want to show you here that doing something as simple as a little roulette game that works off of wind power, that is already meeting all of our expectations from you. And essentially what we want if you're thinking about building a physical project, is that you just build a prototype. It doesn't have to look amazing, but what it needs to do is that it needs to adhere to your statement, so your hypothesis, and that somehow you're able to demonstrate that the function that is performing meets that solution or satisfies the hypothesis. So in this case, if you were to put this together, and I have a video showing that if I have a fan and it's pushing the turbine around, that the ball is indeed going around into these little segments, and if I stop the fan, the turbine stops, the ball starts rolling, it finishes in one of these numbers, and we can then move on to a Jeopardy game that we can then talk about, that gets a conversation going about environmental sustainability. And if you're able to show that, you're already golden in our eyes for what we expect from you. So I just wanted to state this just to kind of put at ease everybody's worries about what we expect from everybody. My hope for everyone is that this is a fun experience and an opportunity for you guys to really try your best at going out there, looking up a problem that you feel passionate about solving, and then looking at what you have available to try and solve it in any way possible. So with that said, the closing remarks, it's one of the things that if you're just starting out and you're still kind of searching around for finding that question, is to simplify your queries. So as I said before, queries are the searches that you input in your search engine, which it could be Google. And again, using the advanced search option is not necessary. I just wanted to bring that to your attention in case you're interested in using it. But what I do recommend is that if you have already a thought in your head, to maybe break it down into those keywords and then that will allow you to get a more broad outcome and results. And maybe it'll show you some articles or some content that you had no idea existed, and maybe it'll bring light to a problem that you didn't even know was out there, and you think that you are more than capable of providing a product that can solve it. The next thing is to always keep your solution statement or hypothesis very clear. Just like we showed there, it's very much a statement, not a question, not a paragraph, just a sentence saying that A is capable of solving B because of this. And then what you will do then is to then provide a solution for it. And I agree that it's good to be ambitious and have an idea what a final product would look like. But then what you need to do is you need to scale it down and realize that it's a hackathon and you have 2 weeks. And there's no way, as Surath said, there's a lot of trial and error that you need to do. Am I correct, Surath?
Yeah. And just to iterate too, like, yeah, these projects can feel very overwhelming if you have, it's great to be ambitious, and we definitely applaud that, but we also want to make sure that you're not overwhelmed with it. And focusing on a few things that you want to solve within your projects can be a great way to really hone in on like the most important parts of your build. So let's say, for example, how do you make the best spinning fins, or how do you make the most stable structure? Kind of focusing on those parts as you do your iterations. And I think that's a great way to just stay simple and make sure that you have a product that you're really happy with in the end.
100%. And if ideally you have an idea in mind, and this product does 100 type of functions, maybe scale it down to just one and make sure that one works and it does a really good job at just doing that one function. And then, of course, as Surath mentioned, putting some thought on what materials you use. I think Surath, you touched on different parts of the structure, making sure that the parts that need to be robust are robust, and the ones that need to be light can be light. And you want to, I guess, reiterate what you mentioned about what type of materials and considering between these options?
For sure, yeah. And a big part of it is being as creative as you can with the materials you have at home. But then, yeah, exactly like what Eduardo was touching on again, was making sure that you have a reason for using certain materials for certain parts. So having that middle axle in our turbine example, super rigid. So what's a really rigid item you can use that you can find in the house? Items that are really light that can catch wind really well. All those kind of considerations are really important, and to give some really good thought into what materials you're using.
For sure. And just to, I'm repeating myself at this point, but don't stress out. We're not looking for the next smartphone. This is just a prototype, and it does not to be perfect. But what we are looking for is that we want to look at your written statement, read the hypothesis, look at your video, and see that your product, the function of the product, is addressing the hypothesis or your statement that or what your solution is. That's it. And I am more than confident that you guys are capable of putting some really cool ideas together. And I am honestly, I guess I reflect the thoughts of the rest of the team when I say that we're very excited to see what you all are going to do this year. So with that said, we reached our Q&A session. And I guess, Blake, if you want to take over, we'll be happy to answer any questions that the participants may have.
Right. So yeah, so there are a few questions here, mostly related to logistics of the competition. But I actually have some follow-up questions that maybe some students may have when they're working on the competition. So with regards to research, what if when I'm doing research and I'm looking up I'm just trying to find information based on some hypothesis that I come up with. What if I find out the results are too complicated? Like, what if I'm having a hard time understanding the results that show up? Thinking that those results would be the best results to use. Like, how do I sort of manage like finding results that are sources that are good and finding results that are also like a bit easier to understand?
So I guess it all kind of relates back to what you're looking up in those in your search engines. So Google is a great source for this. it gives you a lot of stuff, but like I said, it can also lead you to a path where you kind of feel confused. There's a lot of like, it's such a bunch of articles, and some of them are not the easiest to understand. So with my advice would be to go back to the original question, which is tackling issues within environmental sustainability, and maybe just focus on one of the keywords. I mean, uh, maybe you just search up something about what I would search up would be sustainable communities, and then I will follow up with just like issues, something very simple. And that might bring up maybe just a news article about a community that may be struggling with their residents being confused as to where to put their garbage. That's a very common issue in some communities where they have 3 different bins, but they have their garbage in their hand and they just don't know if they should put it in the plastic bin, the compost bin, or the recycling bin. So maybe thinking about like a way that you would educate them on these on this, or maybe create a product that maybe reminds them. Maybe it could be something like an app that maybe has like a little identifier where they can click a button and it shows them examples like, this is an example of something that will go in the recycling bin, and these are kind of like maybe a description of why it's recyclable in the first place, so they can look at what they have in their hand and say this kind of fits the description, and they can put it into the bin. So go back to the original, the objective of the competition, and focus on one of those keywords, and maybe couple it with something that you feel passionate about, whether that be education, programming, maybe something regarding construction. It is up to you. And again, if you do encounter something like you want to go really deep into something and you encounter like a block that you want to maybe read a research article and you have access to it, a lot of us have access to these articles already, so just reach out to us on Discord and we can provide those documents for you if you require.
Great. So we do have a few other questions, but they're mostly related again to the competition itself. So I think I'm going to just briefly address some common questions that are recurring, and then we can continue asking questions to the host. But a few questions I'm getting involve, or students asking, like, how complicated should the project be? Will I have a higher chance of getting into a finals position if I have a more complicated project? To answer that question, given that we're allowing students to have a lot of freedom with their project and what they choose to do, I think that a really important criteria would be having some like creativity in your project, right? Doing something creative and actually pretty relevant to the competition, right? Part of the competition is researching issues related to disposable waste and then coming up with some sort of product to address them. So I think a product that is very relevant to the issues that you're researching and is also a creative or maybe some sort of like innovative solution to it, I think is, I would say is a few of the most important criteria. Is that, yeah, that should answer that question. So again, to reiterate, different students are at different levels of complexity with engineering or coding. I think that's unavoidable. So we're mainly going to be focusing on the creativity, innovation, and the relevance of the project. And that's also reflected in our grading rubric as well that we will be using.
Just to build up on that, when Blake does speak about the complexity and creativity of the project, that can be reflected in different ways. So maybe you have a really great idea in concept, but maybe you don't have the tools right now to build it. And what you can do is just make something simple, but you feel a little bit worried because it's not really reflecting what you want to make. So what I would recommend in that case is to use your project description to really highlight the conclusion section about talking about what the final product will be and why and what the future directions are for it. And if you want to go a step further, you can even, we will have an option for everybody to attach additional documents. That's including a marketing poster or maybe schematics, maybe like a drawing of a rendition of how this will look in the future. That's something else that you can add to your project to give us an idea of where you're going. And that way, if you don't feel like you have the tools or the programming skills to make it, you can at least give us a big picture, and that would go a long way.
There's actually maybe one more thing I'd like to add as well. So maybe, it's a hackathon, and, you have a limited amount of time, and let's say you tried a lot of things, but a lot of things weren't working. And, maybe you're kind of getting a little stressed about making this final product to present, but, all those different steps that you took and the things that didn't work are still like a huge part of the engineering design process. So explaining your thought process of why you tackled it a certain way, why it didn't work, and then what your next step will be to improve on what didn't work, that's a huge bonus to kind of, it's almost like when your teachers ask you to show your work. It's really, get us really in your mindset to see why you did what you did, why it didn't work, and kind of how you're, improving from that. Those are all really key things that you can talk about in your projects.
Right, exactly. To go along with that, that's, I think what we talked about, Eduardo and I and Surath as well, those are the key things that we're going to be focusing on. So we're also getting questions like, oh, what if we address the less common problem versus the larger problem? What if the solution is like simple, but it's effective? So it just depends on, we're really looking for your creativity, innovation, and how you address the problem that you identified, right? And how well your product addresses that issue, right? So you can choose an issue that maybe has less relevance than another issue, but if you can come up with a product that addresses that issue very well, and you can explain why it addresses the issue very well, then I think that's a very solid project to do.
Mm-hmm. Somebody actually asked something really interesting here. Are you able to improve an existing solution? Of course, 100%. But we're not looking for, like, if it's a software, we don't want you to just give us a link to the software and then just write, like, we would add like something else here. If you are making an improvement of a existing solution, we want to know what it is, and we want you to show us, I guess, the base product, and then what's your addition to it, and show us that in the way of the video, or if that's not possible, show us in the way of maybe additional documents of like what you would add. But in all cases, that is completely valid, as long as you're able to write about it, provide a video of your project performing the function, and then if you want, supplementing it with other documents, that is completely fine. That's what we're looking for.
Right. So on that note, related to actually what we talked about, I do have a question for Surath. So in this presentation, we mainly talked about examples related to disposal, waste, and sustainability, but maybe in the research that you've done or are doing now, is there maybe an example where an issue had to be tackled, where like, obviously you couldn't really tackle the issue on like a very large scale, but maybe there was like a solution provided that maybe was a stepping stone to reaching a much larger solution? Because I think that in this project, we may be seeing examples of solutions or projects from students where in tackling an issue, they sort of tackle on a smaller scale, right? So is there an example of that in the work that you've done?
Related to sustainability?
Not necessarily, just, yeah.
Right. Actually, I do have a one that is related to sustainability, but in like maybe a completely different field. So it'll be an interesting connect. So in the work I do kind of day to day now in the biotech industry, we're working on essentially rapid test kits for different chronic diseases. So if a lot of you might be familiar now with the COVID rapid tests that we have to do to see if we have a positive or negative COVID results based on if we need to go to a certain location, or if a need is there to see to doing those rapid tests. So we're doing rapid tests in a bit of a different way, but one of the things when it comes to environmental sustainability is that there's doing one of these tests and we throw it in the garbage. There's a lot of waste that's created by these test kits. So a really important consideration you have when creating test kits like this is to use materials that can be recyclable or be disposed of and in simpler ways, so that we're not just piling the waste bins full of this stuff. So in kind of the work we're doing now, it's making sure that the materials that we use for these test strips can be disposed of. If a lot of them have kind of like paper that's used in the center. So if you kind of think about those test strips that you use, you put your little sample of your fluid from your nostrils with that little bit of fluid, you mix it together and you put the droplets onto your test kit. You see that liquid going through a piece of paper in the center. So pieces of paper are pretty recyclable, but then all the plastic housing is something to consider as well. If there's any type of metals that are used in this, you have to make sure that they're safe to dispose of too. But then of course, there's infectious agents and things like that that could be in the samples that you put into your test strips. So that's another consideration of how you dispose of these items. So yeah, that's just like one example of kind of taking this idea of environmental sustainability to kind of a different field. When we're talking about the healthcare field here, but where thinking about the environment is still very important to provide solutions for. And this is a huge scale, because you were thinking of providing test strips to everyone in Canada, let's say, or whoever needs it, for patients who need it.
Right, very interesting. Okay, so we are going to wait for more questions to come in, but Surath, there was actually a question right early in your presentation. If you can go back to the turbine. Mm-hmm. So there was a question by an individual who said, how would you stop the turbine though?
Yeah. That's a great question. Because yeah, if you were to put this outside on a very windy day, it would never stop. So this is part of the process of figuring out what you want to do for your game. So for example, I think Eduardo mentioned an example where you could just have a fan that you turn on and to turn off so that the wind turbine can stop. But that could be one solution, but then again, you're using energy to turn on the fan. So it's not necessarily just wind. So another example could be, you could create an additional contraption that attaches to the wind turbine, so that when you put it outside, the wind turbine starts spinning. Perhaps like after a certain amount of time, if you have a timer, you could close, you can stop axis or have an obstacle to the wind. It could be like a piece of paper, it could be something like that. It could be something rubber band powered, so that when the wind turbine is turning around, it causes this little contraption to move up and stop the wind after a certain period of time. That's a certain solution that you could have to make it fun. That could be that of course adds a lot more complexity to the challenge too, which might not be something you want to focus on. So you can make it a game where perhaps the kid has to put their hand up just to block the wind. That could be a very simple solution after a certain period of time to stop it. Another potential solution is thinking about how much wind these the cups that we had on the end of our turbine can collect. So maybe you create them so that they actually can't collect that much wind, so that you need an actual really big gust of wind to turn the turbine, and kind of like a continuous slow moving wind won't turn the turbine. So that's another consideration you could take to make the turbine stop, because that's a very important key factor of this game. So that's a great question.
Right, yeah. I think like obviously it seemed like maybe an obstacle, like actually stopping the turbine, because it seemed like it would just keep on going. But I guess the highlight is there are different ways to work around that, maybe different creative ways to work around that. So in your projects, if you may be stuck on proceeding, maybe you think that something's too complicated, especially with engineering, I think that maybe devising some creative ways to address those issues could be a possible path to follow. So we currently don't have any questions from students now. So I think for now, I want to ask some questions to Surath about like maybe a bit more personal questions, not really related to the actual presentation, but maybe sort of questions for students maybe aspiring to be engineers, or computer programmers. So my first question is, have there been any like concepts that you learned as an engineer that's helped you in your current work?
Yeah, no, that's a great question. So I feel like, day to day, you're learning a lot of new things, whether it be in the classes you take themselves or kind of the tiny little things that you learn on your own as you're, making projects and building things that kind of help you in your day to day work. I think, one of the really big things that you carry on throughout my career, it's still relatively early at this point, but things that I've carried on to where I am now from kind of what I did as in my engineering undergrad and different projects that I did is kind of that mindset of how you think through the engineering design process. So we kind of went through it today in a bit, like a little less structured, kind of a bit more informally, but everything we talked about today is how you start with a problem that needs to be solved. And then how that leads to the questions you answer, or sorry, the questions you ask about those problems, the hypothesis you make to address a problem, and then the solutions you make to address everything as well, the hypothesis, the questions, and the problems. So really, like, kind of those big key things that you learn about is you want to create solutions for meaningful problems, and you need to you can't just create a solution for the sake of creating a solution. I mean, sometimes it's fun to just create something that's really cool and then that does something, but you really want to tie that into a problem that needs to be addressed, whether it be for helping people, helping the environment, anything like that, because you always want to build solutions that will help move society forward or help move society forward in some way. So keeping that mindset of really thinking strongly about what you want to solve in terms of the problem. So in this case, it would be, environmental sustainability and helping youth learn about environmental sustainability. That's, the problem that you want to address, and then being very specific about creating a solution that will help address that problem, and not just something that's, just fun to do for the sake of it, but it has a really meaningful impact. I mean, there's there's scenarios that will be great for both of those, but for this case, yeah, we really want to make a meaningful impact.
Great. So I guess maybe a follow-up question to that would be, is there anything that you have done like in middle school or high school that you think it had an impact on where you are today now, and maybe some advice on what students can do at this age now if they're thinking of pursuing a career, something related to engineering or computer science? Yeah, no, that's a great question. And I think, back in middle school, high school, I was very interested in biomedical engineering. So that's, creating engineering solutions to help with human health generally. So, it's a very big field too, but I was back then very interested in prosthetics. So, artificial hands and limbs that could help people with amputations. And so I was very interested in that. And kind of the things that I did in middle school and high school were, continuing out kind of outside of, just the classroom, exactly what you guys are doing right now, finding opportunities to do SRHacks or other hackathons, or any ways that you can kind of continue to enrich your knowledge in these different fields. So because maybe, in school, you might, you're learning a lot of the fundamentals, which are very, very important, having your science classes, and it'll eventually kind of be branched into physics, chemistry, biology, your math classes, all those kind of things are really important fundamentals. And then from there, you can, ask more questions about, okay, so well, for biomedical engineering, I have to think about how is my math going to help me with this, biology problem, or vice versa. And kind of, trying to connect all these different fields together is a really great way to move forward with careers in engineering and science. But of course, it's all based on your curiosity and what you find interesting too. So for me, yeah, it was biomedical engineering, and kind of stuff later in high school, I was really interested in prosthetics. So I had an opportunity in a course to
do some building of prosthetics, very basic stuff, but it was, it really did help me, enrich my experience of kind of seeing that I really enjoyed doing this kind of work in like mechatronics, electronics, and all those kind of things. It gave me a good foundation to then, when I went to university, to like really hone in on what I was interested in doing. So, and in your schools too, think about the different teachers who teach different courses that you really are inspired by, the teachers that really give you great examples of the work that you do and how that can apply in your future careers. The types of teaching that you do that you're really interested in, ask questions to those teachers. They're always there to help and mentor you as well. And they could even provide you more opportunities of things to do outside of the classroom. And I think just the fact that you all are here today doing something like SRHacks and attending Science Rendezvous, that's a great step too, to continue talking to people who are in different fields, and potentially doing projects related to those. I think that's a really good start. Where you are right now, it's great that you guys are doing this. So continue doing it. I think is one of the takeaways.
Right. So I think we're going to wrap up very soon, but I do have one more question for you. So in this competition, students have the option of using coding applications such as Tinkercad, which are block coding applications, but also involve some engineering aspects as well, essentially like three-dimensional models. So in your work that you've done, has there been any instances where three-dimensional models were maybe significant, maybe had some implications for, actual like real life solutions?
Yeah. Oh yeah, for sure. No, that's really true. And it's great that you guys have an opportunity to start working with 3D models. Because yeah, essentially my day-to-day, I do a lot of kind of 3D modeling, things like that. It could be for something as basic. I mean, these are still useful things. Like in my day-to-day work, we have a 3D printer at our work, and sometimes we wanted 3D print things that we could use as little jigs to hold different items that we're doing for an experiment. So let's say for an experiment, we have a bunch of these. So I was talking about how we are building these rapid tests, and we want to do a bunch of different tests at the same time using our, we're in a science lab, so we're using our pipettes. We're putting different solutions onto these test strips and doing different experiments. And we want to automate things in a certain way. So a lot of things I do as an engineer is I use my 3D printer, build something that can hold a lot of test strips at the same time, or allow me to put fluids on all these test strips very quickly at the same time. So building 3D models to build those kind of rigs is something that I do a lot. And yeah, that's something I kind of do in my day-to-day, and kind of just learning about 3D models and how you create them. It's a really great exercise too, I think, to kind of that kind of spatial awareness of, so you're seeing something on a 2D screen, but understanding how it can rotate around and how things can fit together into them. It's like, it's all a part of kind of being an engineer who builds, because, you're using your hands a lot, and sometimes maybe you don't have access to materials to use your hands to build them right at this moment. But if you have this kind of 3D modeling software, you can do it virtually. And I think, these are great skills to learn, and it's fantastic you have that opportunity to do it now. So, and it'll definitely help in the future. So it's great to kind of look into that if you're interested in pursuing it.
Yeah, follow-up question to that actually. So have there been some like 3D models that actually simulated like some like the physics behind actual real-life models, like that were realistically like the 3D models were realistically like in motion, for example?
Yeah, so I do have a few examples of things that kind of had motion. So kind of a few years back, when I was kind of doing a lot of prosthetics type research, I did create like a prosthetic hand design using 3D modeling. So that one actually had joints and things like that for each, of the individual fingers and the thumb. So then when you connect, you essentially 3D model all the different parts, like all the different parts of the fingers, the palm, and their thumb, and then you can kind of connect them together, and then they can rotate around each other, so that they could actually kind of work like a hand. So I did a lot of that kind of 3D modeling. And then I did a lot of 3D modeling for moving fluids around different geometries and contraptions. So a lot of the work I did before was you take, let's say, even a blood sample, which has a lot of cells in it, biological cells in it, and you want to look at specific types of cells that are within that sample. We created these really, really tiny miniaturized 3D models that had tiny little channels in them, so that blood can go through it, and they had different, shapes and geometries that cause the blood to go in different directions, so that we can pull out, the biological cell of interest. And that was just, we're just pushing a sample through this tiny little 3D model contraption, and then you have a lot of different outlets where you can get what you want out of it. So yeah, there's a lot of cool applications of 3D models for sure.
That was very cool. Yeah. I'm only an undergraduate student, but I haven't really been exposed to that kind of stuff. I normally just code on a computer in Python or something. So, hearing about those different types of applications, I think are pretty interesting.
Yeah, that's great.
Yeah, I think we're going to wrap up from here. So if there are any additional questions, please message us on Discord. We'll also be having our mentor office hour starting on April 27th. So you can also drop in there if you need additional support. But yeah, thank you for joining us for the second workshop, and the third workshop will take place on April 20th. That'll be the graphic design workshop from 2 to 3 p.m. So until then, we'll just see you around on Discord, email, and yeah, good luck on your project so far. And oh yeah, thank you, Surath, also for joining us today.
Thank you so much.
Glad you joined.
Take care, everyone.